Hey y'all, today we're going to talk more about the sides in triangles, and we're going to talk about the triangle inequality theorem. So the triangle inequality theorem tells us if we're trying to build a triangle and we want to know if three side lengths will be able to make a triangle. In order to do that, the sum of any of those two side lengths needs to be larger than the third side. So that means if I take the lengths of any of the two sides in that triangle I want to build and I add them together, that addition, that sum of those two sides needs to be a larger value than the length of the third side. Otherwise, when I try and put the sides together, they won't meet to form a triangle. So we want to know, can I make a triangle, or can a triangle exist with sides that are 3 feet long, 7 feet long, and 8 feet long? And so the way that I would do this is I take the two smallest sides, so 3 and 7, and I add them together. I know that the two biggest sides, when I add them together, are going to be bigger than the smallest one. Okay, where I might get stuck is when I take that smallest one and add it to the side that's in the middle. So I'm going to add 3 and 7 and get 10. So in order for this to be a triangle, 3, 7, and 8, in order to make a triangle with sides 3, 7, and 8, this sum, 10, needs to be bigger than my third side, 8, which it is. 10 feet is longer than 8 feet, so the sum of my two sides is bigger than the third side, and therefore I could build a triangle with these side lengths. Again, I'm going to look for the two smaller sides, 5 and 10. Be careful, they're not always listed in numerical order. So I'm going to add those two together, 5 and 10, that sum is 15. And now I need to compare this sum to the third side. And in this case, the sum of my two smaller sides is equal to my third side. Well, the theorem says that the sum of any two sides needs to be greater than the third side, so I haven't met that condition, and so I wouldn't be able to make a triangle with these three side lengths. Let me do one more. I'm going to pick out my two smallest sides, 2 and 6. Again, I've put them all in numerical order. Just be careful, it's not always going to happen. So 2 and 6, when I add them together, makes 8. I'll compare that sum, 8, to my third side, that's 9. 8 is less than 9, so my sum of my two sides is less than the third side, and so I would not be able to make a triangle with those three side lengths. So a triangle with sides 2 meters, 6 meters, and 9 meters could not exist. So I want you to try this one. I want you to tell me whether or not a triangle could exist with sides 4 yards, 6 yards, and 9 yards. Just answer yes or no. And then if you have questions, we'll talk about it in class. So the other thing we can do with this idea of two sides needing to add together to be bigger than the third side is we could have two side lengths that we know of a triangle, and we can create a range of possible values for my third side. So maybe I want to build a triangle that's 8 feet and 12 feet, and then I don't really care how long the third side is. I just want to know all the possibilities for that third side. So in order to do that, I have to create a range. That means I have my value x in the middle. That represents the third side length that I'm trying to find a range for. We're going to have some value that that third side needs to be larger than, and some value that that third side needs to be smaller than. And so what I'll do to find those values is I'll just subtract the two sides that I have, and I'll add them. So I'll do 12 minus 8, and I'll do 8 plus 12. And so my third side needs to be larger than 4 feet and less than 20 feet. So you can see if my third side was 4 feet and I added it to my side that was 8 feet, 8 and 4 make 12, which is equal to my third side. And we already had an example where we said that it can't be equal. If I have 20 as my third side, that would end up being the longest side in my triangle. So if I add 8 and 12, that makes 20. And again, 20 and 20, they're equal. That doesn't follow the theorem. And so we couldn't have a triangle with that size. So our third side has to be bigger than 4, less than 20, somewhere in between. Let's do another one. I want my two sides to be 4 yards and 7 yards. And then I don't care what the third side is, so let's find a range. So we'll subtract 7 and 4, and we'll add 7 and 4. And we'll find that the length of my third side needs to be larger than 3, smaller than 7. Again, if my side was 3, and I added that to 4, that would be 7, and that would be equal to my third side, no good. If my largest side was 11, 4 plus 7 is 11, which is equal to 11, no good. So we have to be between 3 and 11. I'll do one more. Again, I'm going to add and subtract. So 8 minus 5 and 8 plus 5 gives me a range of 3 to 13. So my third side has to be larger than 3, less than 13. So I want you to go ahead and choose the range of possible third side lengths. If I want to build a triangle with one side 18 meters, another side 23 meters, and I don't care how long the third side is.